Hello everyone, welcome to the 16x model evaluation stream. Welcome if you're first time here, and welcome if you have been in our previous streams. So today we have GPT-5. We already did GPT-5 evaluations before, but there's a reason why we are doing an evaluation again today. Is because some people said that the GPT-5 with the default reasoning effort, which is medium, is not a very good model, or should I say that the high reasoning effort is what the magic is for GPT-5. So if you're not using high reasoning effort, then this evaluation is pointless, right? So like all the people who are testing out GPT-5 with the default reasoning effort or the medium reasoning effort, they're essentially not testing the full potential of GPT-5 model. So yeah, I'm gonna do this again with the high reasoning effort for GPT-5. So to do that, back-to-back streaming days, yes. welcome everybody. So yeah, that's the backstory. So I've updated my app 16x eval. So this is where I'm doing my eval on all the new models, and you can see I have GPT-5 and GPT-5 high. So I've updated my app to kind of differentiate between two models when the reasoning effort is different, so we can compare the difference, right? I already did one testing for this TypeScript task, and I can see the difference clearly between these two tasks. So if I go inside, I can see this is the low reasoning, this is the medium reasoning, and then there's a high reasoning effort, right? So this app has already been updated to support this feature, so we can see the difference very clearly as we go along. Yeah, that's the basically the introduction for the model and the background on why we're doing this. Let me see. So we have done that, and let's move on to the evaluation task and how we're doing this evaluation, right? So in terms of evaluation methodology, I've already posted a GPT-5 coding evaluation post. So this is the original post from last month. So this is the evaluation that I did for GPT-5 with medium reasoning effort. We'll be using the same evaluation methodology, so it will be 7 tasks instead of 6 tasks because I recently added a new task, which is the Tailwind CSS v3 task. So will be 7 tasks for this evaluation: 1, 2, 3, 4, 5, 6, 7, right? And for each task, the model will be given one chance, and for some tasks there will be 2, but most of them only 1 try. We do not specify custom temperature, verbosity, and we didn't specify the reasoning effort in previous test, but we will do in this test. So for this particular evaluation, we'll use the high reasoning effort, which is what the OpenAI has. And then all the other rules and rubrics will of course use the evaluation rubrics that you can see on my website. So each task here has its own evaluation rubrics on how we are evaluated this, and all the model output will be evaluated by a human, which is myself, to manually assign the rating to each output. So they are all rated by human instead of automated rating. I will use some scripts to kind of do some automated evaluation, but the final rating will always be given by a human to account for machine judging errors. So that's the rating part. That will cover our evaluation methodology. So without further ado, let's move on to the proper evaluation. So for the first task, we still have our Tailwind CSS v3 the index task. So yeah, this is a task that is created by myself based on a real life problem that I encountered with the model. I should say that all these problems are based on real world tasks or bugs that I encountered. So they are not some synthetic benchmark or like a coding exercise. These are all real world tasks. So for the first one, I've actually done a test on the TypeScript task, but not for this task. So let's go in and test this one out. So you can see here I have all the models and their scores here, ratings rather here. So what I'm gonna do is for this task, I'll create a new evaluation based on this particular evaluation with GPT-5. So you can see all the prompt and context are carried over, but I'm just gonna open the advanced setting and then change the reasoning effort to high. So this will be using our high reasoning effort for GPT-5, and then we'll get back the response, right? So we'll be expecting this evaluation to give us a longer, much higher reasoning token count compared to the normal GPT-5. So if we see a much higher token or reasoning tokens, that means it's using the high reasoning effort. Yeah, so basically that's how we're gonna tell that we're doing the right thing and we're using the right reasoning effort by looking at the reasoning token amount, right? So yeah, so this is gonna take a while. Let me go to the OpenAI platform and then let me look at the settings or the dashboard, look at the logs here, just to verify we're actually talking to OpenAI API. So you can see here we haven't got the latest log, probably still processing. It's gonna take a while because this is a high reasoning effort. Yeah, so a lot of people are complaining about GPT-5 is that for me at least it's very slow because you need to wait for very long. Yeah, so that's basically a downside of high reasoning effort, is that you need to spend a lot of time generating thinking tokens before you get the final response, right? So the waiting time is kind of much longer. I think normally other models would have already completed this. You can see here other models take like 14 seconds or 2 seconds, 50 seconds. So yeah, so this is on a slower side of things, definitely still ongoing. So while we're doing that, we can take a look at the these tasks or what this task does, right? So this is this Tailwind class is basically a task is to identify a bug inside the code. So this is the full prompt. If we open this project, which is the Tailwind CSS task, if we open the index.html, we can see that there's a button here. If we click it, it will the button will block the model. So this is the bug, and the bug is because of a invalid Tailwind class, which is Z60. So this is invalid class. So basically we're testing if the model can understand that this is an invalid task in Tailwind v3, because Tailwind v3 only supports up to Z50, not Z60, right? So that's the task. Let me check. Okay, so it has completed. So you can see it took 124 seconds. That's 2 minutes. I think that's the slowest. Oh yeah, this is sorting by speed. So let's see. It doesn't sort by total duration, unfortunately. So let me see if I got a slower. Yeah, Grok is much slower, so 251. Yeah, I think this might be the second or the third slowest. Yeah, It's just slightly faster than group 4. Hello everyone. Yeah, so for Tailwind, let me close something. All right. So for Tailwind version 4, right, it actually fixed this bug. So in Tailwind version 4, this is valid, but this is not valid in Tailwind version 3. And we explicitly tell the model that this version 3, so so the model, we're testing the model whether it can understand it's version 3 and it has this bug. Right? Hello, Yangming, welcome. So let's see what GPT-5 respond with. We can see it spent 3,000 thinking tokens. The speed is actually quite fast, 65 tokens per second. But because it need to generate 3,000 thinking tokens, that's why it's taking quite long. If we compare to Gemini and Grok, it's about the same. I would think this is actually lower. If we compare to the normal GPT-5, you can see the normal GPT-5 with medium default reasoning effort is 1,600 tokens or 1,300 tokens, and this high reasoning effort is 3,500 tokens. So it's definitely using a lot more reasoning tokens. And if we go back to the OpenAI logs here, you can see we can see that our request got sent to GPT-5. So unfortunately, I don't think this will tell us the reasoning effort, but at least you know, we are hitting the right endpoint. So let's take a look at this response, right? Okay, so immediately we see it tells us the bug is invalid in that class, which is good. So looks like this is the correct fix. So let me just copy this code. Sorry, I need to copy this model first. And then I'm gonna create a model response file inside my eval data. So I'm just doing this to collect all my model results so that I can kind of collect all the results and then post them publicly. Yeah, so just for safekeeping reasons. I think for this task we actually give 2 tries for each model. So this is gonna be the first try. And let's see how well it does. So we have the model response here, GPT-5 high. And if we open this and then open settings, so we can see there's no blocking here. So the bug is resolved. And we have a automated script to kind of test how well this did, right? So let me just run this automated script. I think it's npm run test. And then I have a verbose flag. Yeah, so we can see it actually fixed the invalid class and then it used the correct custom values. So what this means is that it actually used the correct syntax, which is z dash bracket 60. So this is a valid syntax. There are other ways to solve this, but I give bonus points for models that use a custom valid syntax because it's kind of preserving the value 60. There are other methods to solve this bug by changing to another value, but I would like the model to keep the original values like 50 and 60. So that's why I give a bonus rating for models that use custom value syntax. Unfortunately, I think it didn't remove the unnecessary z-index classes, which is this one. So it won't get the bonus point for that. So basically this is bug identified and fixed plus 0.25 for using custom value syntax. So this model will get a 9.25 rating. So it will put it exactly at the same level as the previous GPT model. You can see here, if we sort by model, it will basically be the same here. But for this task, each model is given 2 chances. So let's just run it again with I, and then see if the second run will be better. I doubt so, but let's just try it out. I think this is gonna take a while, like probably 2 minutes. So while it's doing that, we can talk about, I guess, but if I talk about the next task, then the stream will be very messy. So let's not do that. Let's just wait for this to finish. Yeah, so looking at the result, I would expect GPT-5 high reasoning effort to be better than the medium, because you can see here in my previous evaluation, GPT-5 did very poorly, primarily due to one task that it wasn't able to solve. So it's actually behind GPT 4.1. This is the medium, but I think with the high, it should be doing much better. Yeah, so this is gonna take a while, like 2 minutes, I think, for each response. I don't know if anybody is actually using GPT-5, like in Cursor or in Codex. If you are using GPT-5 high, you can let me know like how fast it is. Is it usually this slow for each task? Is it like much slower than Sonnet or like similar speed? I personally think GPT-5 high is quite slow because they need to generate all these reasoning tokens. So let's see this one. Okay, so this one looks quite similar in terms of the fix. Let's also run it through our evaluation process. So this is gonna be the second generation. I'll copy this code here. First, I got fast version. Oh yeah, maybe that's why it's actually fast, right? I'm using the API, so I don't know if this is the fast version or the slow version. But anyway, it's quite slow for me. Okay, so it fixed the index and removed the extra index value. Oh, okay, so it gave a different solution. So for this case, yeah, it actually didn't use the z dash bracket syntax, right? It just, like I said, it used the alternative way to fix it. Instead of still using 60, it just used 50, and then remove the other z index values. So that's the alternative way to solve it. This will still get a 9.25 because it fixed the bug and then removed the extra z index value, but it didn't use the correct custom value, so it won't get this plus 0.25, so it's still 9.25 anyway. Okay, so we've done the GPT-5 high evaluation for this task. It's the same as the medium, 9.25, no change there. If we come back to this rating chart, you can see this is updated. We have 9.25 for medium and 9.25 for high. Let's move on to the next task. So the next task is clean Markdown, which is a medium level task. Let me just run the task first and then explain what this does. So this is the medium clean Markdown task. Let me create a variation of GPT-5 with the high reasoning effort and all the prompt and context. Run the evaluation. Okay, so this clean Markdown task is also a task that is based on a real life thing. So we need to actually clean the Markdown. So this is the full prompt. Basically, given that we have a simple Markdown file like this with some formatting, gray matter like heading, tables, and some Markdown component like this, and some code block, we ask the model to clean the Markdown text and then return a plain text file. So basically, given this input, we want the expected output to be like this. So with no formatting. So unwrap the code blocks, unwrap the links, replace heading with plain text, remove all the other components. So yeah, so this is the full prompt. It basically tests the model's ability to write a very long procedures or regex. So this is the expected output, and then I think this is the sample input, right? So you can see it just basically cleans the Markdown into a plain text file. Okay, so GPT-5 is still running. Not unexpected, but it's very slow. I think for this task, the rubrics is quite simple. Each model is given one try. Yeah, so this is quite slow. I think, I don't know why it's very slow, but this is what I'm getting from directly connected to OpenAI API. I wonder if there's some speed syntax, speed parameter, like speed matrix here. I don't think so. Yeah, there's no speed matrix here, so I can only see the input and output. I think if I switch to responses API, I will get it, but I haven't implemented the responses API yet. Okay. Still waiting for GPT-5. Yeah. This is why I don't like reasoning models. It's just takes a long time to generate tokens, to generate the actual response. I think I have a blog post on this that explains this process. So if I go to my post here, so basically if we give a model an input and then output, and then it has reasoning. Actually the reasoning should be above here, so it's actually outputting the reasoning first before it generates the output, right? So it's kind of the graph is a bit wrong. Basically you need to generate the reasoning token before it generates the output, so this part is taking very long. Okay, it's still running. I think this might be the slowest model for this task. Let me see. Yeah, so this is the second task. And we're just waiting for GPT-5 to finish thinking. Okay, finally finished. So it took 376 seconds, which is about 4 minutes plus. That's very slow. Yeah, that is very slow. It's like much longer than the group 4, which is about 200 seconds, right? It took 13k tokens. Wow, that's a lot of thinking tokens. That's higher than all the other models. So GPT-5 spent more thinking tokens than all the other models, right? Even more than Grok 4. So that's the GPT-5 high reasoning compared to the medium. So you can see this is 8,500 and this is 13,000. Yeah, 13,800. So it's much higher. Okay. Oh wow. What the hell? Why the code is so long? This is such a long code. Oh my god. I think this might be the longest response as well, right? So the previous longest response Oh, I guess the previous GPT-5 is also quite long. Yeah, so I guess GPT-5 just generates very long responses for this task. So if we sort by the length, you can see group 4 is 2.5K, and then GPT-4 is 4.7K, and then GPT-5 is just on a league of its own. That's interesting. So very high reasoning token count and very high number of response. The code is very long. Let's see how well it does, right? This is a very long code compared to other models like you can see the GPT, this is GPT OSS 120B, and then if we look at maybe Kimi K2, it's just very short code, and then you get GPT-5 high, which is this long, right? This is like 200 lines of code. It's just extremely long. Let's see how well this does. So let's run the code and then see the output. I have a script to run this code, and then we can check the output. Yeah, thank you Marcia for the support. Much appreciate. I have the script to evaluate this. Let me check what's the script called. Still test verbose, so I'm just gonna run it. Okay, so we got GPT-5 high, 100% match. Nice. So the GPT-5 code outputted this response, which matches 100% the expected output, right? So it got 100% correct, which is very good. That means it should score very high for this task. But unfortunately, fortunately we don't penalize for very long code. We only penalize for verbose output. I don't think I've given verbose output to anyone, so I'm not gonna give verbose output to GPT-5 high. It's just a very long code. I don't think it's necessarily a bad thing, so I'm not gonna penalize for that. So based on that, I'll give it a correct rating. It won't get the short code additional bonus because that's very long. This is like way longer than I expect, but it does solve the problem. So it gets 9 out of 10. I think I should note that maybe this task is a little bit unfair for GPT-5 because I didn't actually specify in the prompt that the code need to be short, right? So the model is free to generate longer code or shorter code, but I still give bonus 0.25 to the model that generates short code. So it's like a hidden evaluation criteria that the model doesn't know. I think this is just a personal preference. I just prefer the code to be shorter, and it might be slightly unfair to models that prefer to generate longer code. I think this is a reasonable expectation to have. Basically, you want the code to be short so that it's easier to review and easier to modify, right? But I think that's a reasonable thing to have, even though it can be a little bit unfair to some models. So that's the clean Markdown task completed. So we come back to our benchmark. You can see we have completed 3 tasks. So let's move on to the next task. Clean Markdown is done. Okay, so the next task is clean MDX, which is a difficult task. So I'm gonna run a model and then explain what this task is, just to save some time, because this model is really slow. So I'm gonna find GPT-5, create a variation, go to the settings and change the reasoning effort to high, and then run it. Okay, so the clean MDX is basically a harder version of clean Markdown. You can see the full prompt is here. So similarly, we need to clean a MDX file, which is like an extension of Markdown file, into a plain text file. It's similar to the clean Markdown, but it has more rules and more things to clean, right? Like nested component, and then we have the import statements here that was not there in the previous task. So this is a harder task to complete. And we can see the models generally do not output perfect output, right? So this is what we expect as a clean output. And then for the top models even, you can see there's some artifacts here, some components not being removed, and then sometimes the new line is not there, or it even removes some of the text, right, which will penalize. So that's this task, which is quite hard, and this is the rubrics for the task. Each model is given 2 tries, so this is the first try. Actually, I should run 2 tries in parallel. Why didn't I do that? Yeah, I should just run 2 tries in parallel. Oh, but my app actually cannot do that. Yeah, so I should modify my app to run two runs in parallel for the same model, same configuration. That will save some time. Yeah, I think I will do that very soon. Otherwise, I have to run this for twice as long. So while we are waiting, let me just create the necessary file here. So this will be GPT-5 hi1.ts. So this will be the first response. Let's see how well did the GPT-5 do for this task previously. So it got a 8 for this task previously, right? This is the medium. Previously got an 8. And we're still waiting. Very surprisingly, Grok 4 is very good at this task, so it got a 9 rating, like a perfect response for this task. No other model has gotten a 9. As usual, this is a very slow model. Let me see the logs. How much usage have we burned? I think we burned quite a lot of usage today. Oh, it's not updated yet. Okay, that's interesting. Yeah, looks like this is not real time, right? Oh, this is a spending. Yeah, sorry, this is a spending, so it makes sense that there's no. Oh yeah, here it is. So we have the GPT-5 input token only 2000. Why is it input token? Yeah, this is weird. I don't like this. It's very little information. Okay, anyway, we've completed this. So again, very slow, 188 seconds. I think it's just, oh, it's actually faster than the medium. And in terms of the thinking tokens, this 13k again, which again is the highest. Okay, it's actually less than Grok 4, so for this task it didn't think as hard as Grok 4, assuming all the tokens are equal, which is not true. So yeah, so let's copy this and then run the second one. Let's copy this, and then I'm gonna immediately run the second one. Oh wait, actually I shouldn't. I should reevaluate this first, because later I will get confused which one came first. So let me do clean mdx and then run the test. Okay, so it's not a perfect output. We have 3 differences. So it looks like it left over some artifacts from the component, didn't completely remove the component. So there is some mismatched here, diff here. So So some new line issues, some leftover component. Yeah, some new line issues here. Some new line issues here. Okay. Okay, so let me give it a rating. So I guess we have 3 new line issues here, 1, 2, 3, and then some leftover component. So that will be 9, minus 0.5, minus 0.5. So it's 9 minus 0.5 minus 0.5, which is 8. Okay. So we got an 8 out of 10, which is not bad. It's the same as the previous GPT-5 medium. Okay, so let me run it again with high reasoning. Yeah, so basically I think it did the same as the previous model, which is not a very good sign for this task. I would expect it to do a bit better, but that's what we got. But for this task, each model is given 2 tries, so we still have 1 more chance to do better. And let's see if it does better. This is gonna take about 3 minutes. 1/8 divided by 60. Yeah, 3 minutes to finish. Just to finish a hypothetical function, it takes 3 minutes. It's very slow. I wonder if there's a faster GPT-5. Let me check if it's indeed there's a faster way to get this. Doesn't seem like it. Yeah, doesn't seem like we have a faster way to get this, unless I'm missing something. There's no like turbo or anything like that. Maybe it's just cursor has some special treatment. Yeah, there's no turbo thing, right? No turbo thing. Yeah, unfortunately, we just need to wait for 3 minutes for this task to complete. Let me look at the current model evaluation score. So you can see GPT-5 with the medium is actually quite low. For this task specifically, playing MDX, Grok 4 is the highest, followed by Gemini 2.5 Pro, surprisingly. And then all the other models basically got 8 out of 10. And then the Sonnet model is actually worse on this task. So this is where you know, some other models actually perform better than Sonnet, right? So this is kind of shows that even though Sonnet and Opus are the best models overall, they are the best models overall, but for this particular task, they can still perform worse than other models, right? So it's not like the best model just outperforms other models on all tasks. It actually depends on the task itself. Yeah, so if we come back to here, we can see even though Opus and Sonnet has the highest overall rating, they actually perform worse than Grok 4 and GPT-OSS on this task, right? So yeah, so I think my evaluation tasks are pretty good in covering different types of tasks. So no model is actually like strictly better than other models. Obviously, I'm gonna keep adding more tasks to this so that it's become more representative of the different kind of tasks, especially focusing on JavaScript, TypeScript, and front end. Focus on real life coding tasks. So I'll be like writing code and encountering some problems that the models are having difficulty in solving, and then I'll kind of encapsulate the problem into a challenge or eval task. and then add it to my coding eval. So that's how I get the new tasks from real life coding examples. Okay, so this is the code that got generated. It's very long. Again, it's very long. Yeah, so let's try this out, see if it works. Oh wow, it's actually worse, huh? Okay, so it looks like it's just pretty bad overall. It's like performed way worse than the previous one. So it's like the previous one only 3 diff. This one, oh, we got 20 diffs. And I think some text got removed, right? I think some text got removed, if I'm not wrong. Supervise something. Yeah, so there's the supervise something here. And then the supervise something is gone here. Okay, so definitely some text got removed. Some text got removed, and then we have leftover components. Yeah, so basically 2 problems, right? Text got removed and some component issue. So text remove and some component. So that is 8 base score, and then leftover component is minus 0.5, so that is 7.5. Okay, so the second try actually did worse. So the previous one got 8 and the second try got 7.5. Overall, we picked the higher score, so it will still be 8 for this task. Let me just highlight GPT-5. Oh, actually highlight the first one, never mind. Okay, so that's this task. It's exactly the same as the before one. Let's move on to the benchmark visualization. So the next task is benchmark visualization task, which is a difficult task on generating a visualization of benchmark. So basically we give the model some data. I don't know why this is not loading. Yeah, so we basically give some data to the model, and the model will generate some kind of visualization like this. And we'll see which one generates the best visualization. So let me just run the task first. For this task, I think each model also have 2 tries. I think, let me check. Sometimes I run this so frequently that I forgot. Oh, okay, so only if the code didn't run, then we give second chance. So this is the prompt context and reasoning effort high, and let's run this. Yeah, so for this task, we can actually take a look at the generation from other models. So on the top, we have Opus. So all the top models will kind of show the result of 2 benchmarks side by side. So you can see, for example, for Sonnet, it will show the Aider score here and then the K-core score here side by side to show like if one model is performing well in one benchmark but worse than the other one, something like that. So yeah, so that's the comparison part. And then if we move down to lower rating, it's just basically two bar charts. And then we have some very weird charts like this one, very hard to read. And then we have some very bad colors. And then this is Horizon Alpha, which is like dark mode, and then very hard to read. Interestingly, DeepSeek version 3.1 also gave a very similar graph like the Horizon Alpha, so yeah, didn't get a very high rating. And then you have visualizations that are just not readable. Yeah, so that's basically like a wide variety of output. So let me prepare the file to how to host the output. GPT-5 hi HTML. So we're gonna put the output here and then open it. Okay, still generating. Gonna take a while. Let me see who is the best. What's the best model for this task currently? Oh, it's the Sonnet, Opus, Grok 4, and K2. Yeah, so basically I have all the top models here. They are all like very easy on the eye and very easy to read. I think K2 is the only model that has a solid versus hollow bar charts, which is very nice. So it can differentiate two benchmarks while also keeping the each model with different colors. So that's very nice. And I'm quite curious on what's GPT-5 highest generation. I think it's gonna do at least as well as GPT 4.1, if not better. Yeah, the previous GPT-5 model didn't generate a very good output. Let me see if I can find it. Oh, I actually cannot find it. Where's the previous GPT-5? Oh, there is GPT-5. Okay, I think I forgot to add the GPT-5 output to this task, so it's 8.5. Let me just add it. It'll be somewhere here. GPT-5, 8.5. Yeah, seems I missed it. 55 medium. No labels. Baseline with clear labels. Yeah. I think that's what it does. Yeah. So this was the previous generation, which is pretty good. I think it's pretty good. Baseline with clear labels. Yeah. Okay, let me update this. Okay, so we have the high generation done. In terms of tokens, 7,000, which is higher than the previous one, which we expect. So this is the HTML file. Okay, somehow my script didn't detect that this is HTML. Oh yeah, it didn't return in Markdown format. Yeah, this is the problem with GPT models. They don't return in Markdown format. But it's fine. We just copy everything. And then we just open this file. Okay, that's interesting. We have some over effect. Okay. Let me see. So okay, so there's some nice hover over effect. That's pretty nice. So when you hover over it, it kind of highlights a model and then show you the relative comparison between two benchmarks. Oh, that's very nice. That's very intuitive. I think that's a very good touch. I haven't seen any other model do this. It's definitely a first time. Yeah, it does allow you to compare the performance of the model across two benchmarks, right? This is very good. This is very, very good. I'm very impressed. I'm very, very impressed with this implementation. I've never seen a model that does this. So it's actually dynamic. I have to take 2 screenshots for this. So let me just take a screenshot of this, and then take another screenshot showing the hover over effect. Yeah, this is very good. This is very good. So let's see, how do we evaluate this? So it's not side by side, so it starts with 8. But it does have alternative ways to differentiate benchmarks, right? So even though it's not a side-by-side visualization, I do need to give it this bonus point. And then it's also quite visually pleasing, I guess. I guess so. It's okay. So that would be 8 plus 0.5 plus 0.25. Wait, there's also clear labels, right? So clear labels, visually pleasing, differentiate benchmarks on hover. So highlight benchmark on hover. So this is something different. I'll give it for this plus 0.5 rating here. So that would be 8 plus 0.5 plus 0.5 plus 0.25. So 9 plus 0.25 is 9.25. Okay, they got 9.25, which ties with all the other models for the highest score. Okay, pretty cool. So let me copy my screenshots here. This is the first time I need 2 screenshots. GPT-5 hi raw 1, hi raw 2, hi 1, GPT-5 hi 2. Let me annotate this. GPT-5 hi. Oh shit, I closed it. GPT-5 hi. Okay. I need to write something for it. Put it here. GPT-5 hi. Rating. The graph was also interactive upon hovering, which I should be using whisper flow actually. Upon hover, it actually highlights the current model and then show it across 2 different benchmarks for easy comparison. Yeah, so I think this is pretty good. Gonna add both. GPT-5 hi 1, GPT-5 hi 2. Okay, so these are the 2 PNG files. Yeah. Okay, so that's for this task 9.25. If we come back, okay, so this is definitely an improvement over the previous one. The previous one was just 8.5, now it's 9.25, which is much higher. Yeah. Okay, let's move on to the next task. which is a normal task, folder watcher fix. So let me just run it and then explain what it does. Reasoning effort high, okay. So this is a very typical task on a feature. So basically we give a feature for the task, for the model, which involves a very long file. The model need to figure out how to add a very simple feature, which is to kind of handle ignore suffix when auto adding file. So this is some very simple feature, but the problem is this code is very long, so the model need to figure out where to edit and then only return the files that are need to be modified, right? So only show the relevant code, don't output the full code. So it tests the model's prompt adherence, whether it's good at instruction following. So that's the rubrics for this task. I think the top models all got pretty good score, right? Yeah, so 9.5, 9.25. Yeah, unfortunately GPT-5 in medium was quite verbose, so it didn't get a very high score last time. Let's see this time if it can do better. For this task, I think each model only get one try. Yeah. Okay. See the logs. Yeah, I wish I can see the more interesting stuff like time and everything. There's very little information here. Okay, it's done. Let's take a look at the reasoning tokens. So 3.7k compared to the previous one, 1.5k. So definitely a lot harder. I'm seeing the automatic evaluation result only give 0, so that's a bit weird. Let's see. Maybe it's a bug for my code. Yeah, it's a bug for my code. It doesn't automatically update. Let's see. Okay, so this looks to be correct. And then in terms of verbosity, it's about 3,000 characters, which would mean it's quite verbose. Yeah, it's quite verbose. It did have extra logic, I think. This is does it have extra logic? Let me check. Oh no, it didn't have extra logic, so it didn't implement the extra logic. So that would be soft and verbose, which is 8.5, actually lower than the previous one. Which is actually lower than the previous, not by much, but still a minor missing point. Still quite verbose. Let me see if my prompt is already quite explicit, but it still gives me a lot of code that doesn't need to be changed, like this part. So I think definitely the instruction following is not as good as people claim. At least for my prompting style. I haven't modified this prompt specifically for GPT-5, so that's what I have. So if you come back for this task, actually GPT-5 High is slightly worse than the previous model. But I think overall it's still pretty strong. So that's for it for this task. TypeScript narrowing is a task that is very challenging for all the models. I've actually run this task before just for testing purposes, and the model did give a good output that the both solutions worked. So for this task, you basically need to solve a TypeScript error by using proper type narrowing, which is a very uncommon technique. So a lot of people and models struggle with this task. So if we come to here, you can see not many models can get this correct, and I think GPT-5 previously failed with medium reasoning. But I did run one test like yesterday or something, and it did get this correct, right? So that's just one of the two tries. I think I'll still run it again, but because it's already got 8.5, so I don't think it can get better scores. I think the 8.5 is the highest for this task. So yeah, I think it will be still getting a 8.5 for this task. 8. Yeah, so 8.5 is the highest rating for this task. I think the model will also get 8.5. At least we can test the variance to see if in both tries it actually solved it. We move this here. Okay, it's done. So we have the high here. Let me delete the low reasoning, just those were for testing purposes. So I'm just gonna delete them. Okay, so for this one we have two methods. So I guess this one is the in method, and then this one is alternative. Actually, I don't think this would work. Okay, interesting. So this is the second time I'm running this, and then the second try, it looks like GPT-5 high actually didn't produce a very good answer. That's interesting. So this is the first output. Let me copy this code here because it omitted this. Okay, so this is the first output. Oh, okay, it did work. This worked. It's the using the in keyword. Okay, and then the second one. Okay, so this is recreating the full code, and then let's try to run this. Yeah, it failed. So it provided two methods and one of them didn't work, and one used the in keyword. So one method wrong, one wrong method. Okay, so that's gonna be 6 minus 0.5, right? So I won't consider it the final answer because it's just alternative. Yeah, so that would be actually 6 minus 0.5, which is 5.5. Okay, so that's gonna be a lower score. But unfortunately for GPT-5, when I tested it yesterday, it did give two working methods, so that's I'm still gonna keep this score for this task, so it got 8.5, which is pretty good. And then so that's for this task. Now let's move on to the last one, which is the Next.js. Very simple one. Yes, let's do this. Okay, so this is a very simple task that just tests the model's ability to handle some very basic tasks on a to-do app by adding a created at field. So it mainly tests the instruction following and whether the output is concise. Yeah, so I think I have about 3 prompts to try for this task. Yeah, I'll need to run 3 evaluations. Yeah, I need to add a feature for my app to run different prompt variations in parallel so that I can save some time, I think. Alright, so for this task I actually written a evaluation function within my app. So this is something I have created recently, so this will just automatically run this script and give me a score. So let's come back here and see. Well, we got a 9.5. Okay, that's pretty good. So GPT-5 got a 9.5. Yeah, it looks pretty short and very concise. So yeah, that's already the highest score it can get. So I'm not gonna try another prompt. So this is basically the highest score. Very concise. 9.5. Yeah. So now it's yeah, basically it's the same as the previous one. No difference here. So both the medium and high get a 9.5 for this task. And now if we come back to the final result, yes, this is what everyone's waiting for. This is the final result after finishing all the tasks. So you can see across 7 tasks, GPT-5 I got the top score for 4 of them, compared to GPT-5, which only got the top for 2 of them. And the average rating is 8.86, slightly lower than Opus, but higher than Sonnet, and higher than other models as well. I think this is the second highest rating. So let me double confirm. Let me clear all and select top 5. So these are the top 5 models. Okay, I think there's a bug in my code, so it doesn't consider GPT-5 as one of them. But if I select GPT-5, then it will show up here. Okay. Yeah, I think these are the correct scores. Yeah, there's no bug in the final output. But GPT-5 High is much better than GPT-5, and like slightly better than Sonnet, but I wouldn't say like definitively better. For example, for this task, Sonnet got a higher score. Yeah, so yeah, definitely people were right in saying that GPT-5 High is a very different model from GPT-5 Medium. It did better. In terms of speed, it's definitely slower because of the reasoning tokens. You need to generate a lot more reasoning tokens, so you need to wait much longer to get the final response. But it did do very well on more challenging tasks. So that's the conclusion on GPT-5. High reasoning effort, very strong, but also takes a long time, right? Okay, I think that's all I want to cover for this particular stream. Yeah, thank you everyone for watching, and I will see you in next stream.